Howdy, everyone. How's everyone's day going so far? Cool. So wanted to make a quick change. Figured afternoon hump, everyone's a little tired. So I'm going to talk about lessons from supporting a software modernization effort, or lessons learned from when your clicker doesn't respond. OK. I'm going to change this, avoiding train wrecks, talking about a software modernization journey. And see if our technical works. Just see if we can make it a little more interesting. So we all love train wrecks. Whether it's on the news, videos on YouTube, we talk about them, they're exciting. But we're also talking about it a bit as, I'm glad that's not me. So being in the middle or being associated with the train wreck is far less pleasant. In this talk, I'd like to look at the potential causes of wrecks and some actions we can take that help make them less likely. Kind of the way to think about it is building a new application without thinking about the infrastructure is like driving a train without building the tracks first. You can see the results of doing that. Many in federal IT, I assume there's plenty of federal IT folks here, are working to modernize their systems to deliver new services, retire legacy systems, and enhance their operating efficiencies. Implementing DevOps is kind of a big deal, seeing where we can improve our processes. Few people come in planning to fail, but there are failures due to applications, there are failures due to design, and surrounding factors. So for the next half hour, I'd like to look at some of the lessons learned from supporting a software journey from the perspective of the infrastructure and the platform side. So before we go, I'd like to get a feel for people's backgrounds. So if you're come from more of a dev background, can you raise your hands? OK, ops folks who don't want to admit that they come from an ops background, salespeople, always one of them. Any other backgrounds? Security? Cool. Thank you. If you didn't raise your hand, you should have. So, yes. Cool. So a little bit about me. I have an ops background. I am an ops guy. So I focus on DevOps evangelism, but really focusing on how we help customers design and build runnable systems. Applications are that thing that does something. It's great to have it up. I expect the web pages to be up. But exactly what it does, I'll leave that to the development teams. I like to work on tooling, process, culture improvements that help to the reliable operation of production systems, and big fan of the site reliability engineering approach to doing operations where people are working together. I've been doing IT in the federal space for about 6 years. Actually came from startups originally and small software companies, so kind of a few different opinions on how we do technology. So that's a little bit about me. Want to do a couple disclaimers. One, I'm talking about failures here. We're talking about federal failures, but pretty much every organization, every industry has various failures, some that are pretty spectacular. I don't think any of us has had the FAA announcing for 6 months, if you have one of these phones, please get off the plane. So we've probably all done better than that. The second disclaimer is I get a lot of freedom to talk about case studies, lessons learned, stories from within federal agencies. But at the same time, customers don't like hearing that we're talking about their issues. So I'll be speaking about your generic large federal agencies here. But if you do happen to know who I'm talking about or have an inkling, please keep it to yourselves, because that would affect my ability to come and present talks like this in the future. So let's dive right in. What are some factors that we need to think about as we're going forward and starting this modernization journey? We've said, we want high-speed rail. In Europe, they've got TGV and ICE and all these awesome things. Well, as you can guess, we're going to talk a little bit about trains today. So we want high-speed rail here. Let's do a solicitation. Let's build something. We want to sell it. We want it to be a 150-mile-an-hour train, get some nice high-speed stuff up the Northeast Corridor. But there's environment limitations that we have to take into account. We want to run this on the same infrastructure we're running our legacy trains. Some of the tracks were built in the 1930s. The power distribution system, there are limitations that we need to be aware of. knowing the processes that our organization limits us to so that we don't come and say, well, Google's doing this awesome thing, and they can deploy containers in seconds, and they're deploying billions of containers a week. Why can't we do that? Well, we have different processes that we need to follow. So the example, this story that we're working with an organization, they came in and said, yeah, we're going to do rapid deployment. We're going to have data centers all over. And then security and compliance came in and said, well, you need to do this 12-month manual process and a system of checks. Well, that kind of can be a challenge. Then they came in and said, oh, we have this limited network structure, and we don't have high bandwidth links between the data centers, and you actually can't run active-active across all these data centers because the performance isn't there. These are some environmental limitations that cause engineering to have to stop and do a lot of rework and say, well, maybe active-passive is good enough. Maybe we can shard the system otherwise. And identifying commercial products that maybe you'd brought in and said, this will be, say, my monitoring solution, and it turns out it couldn't work over the limitations. The lesson of this is that as you're starting to think about what things look like, what you're going to be tackling, is understand what your environmental factors are so that, one, we don't sell to our customer and say, we're going to make this awesome system that's going to be completely resilient, then find out, oh, the tracks that we're working on just can't support the speed. Or that, hey, there's not enough of a power distribution system to have this high-performance system. Understand what you can do. The next thing that a lot of places go, and they kind of have this ooh, shiny moment. I can build this new thing. Containers come up all the time. Probably half the talks here, someone's talking about containers. Or microservices, starting running across active data centers, et cetera. Maybe you've got a mainframe system that you've been using, and it's very stable, very reliable processing. Kind of like our steam train here. It's reliable, it's running, there's absolutely no problems with it. So not my story, so not going to talk a bit about it, but there's a federal agency where all of their processing is being done on mainframes. They have web systems in front of it. You've got your web UI. Because that system works, it's stable. The code has been tested, tried and true. Be careful when starting to do a modernization effort that it's not just saying, hey, this technology is new and shiny and I want to play with it, and saying, let's throw away something that maybe is a little old. Figure out if the process you're trying to solve, being able to rapidly deliver test code, is it really about the technology itself, or is it about the processes surrounding it? And the technology in and of itself is good, is stable, is reliable, and we can make some process tweaks. We can continuously integrate code using a mainframe emulator and use that to then focus on the pieces that give us better business value, which might be the web front end that's fronting it, or maybe some processes, or how we test. So along those lines, and it's going to come back to time and time again, is communication. So this is a train crash from a Denver system. Turned out their communication system went down. They deployed a train on the tracks, and it was running, and they had no way to call and say, hey, we need to make some schedule tweaks. It didn't work so well when it ran into another train that was sitting on the platform because they didn't know that the platform was not supposed to be used because of the systems. So story about this is years ago we were working on a system where logging was really important, and the application sent its data over, and it did some interesting stuff that isn't really relevant to this talk. And the vendor said, great, we're going to build a custom logging stack that will deliver the logs into your system. Well, the vendor did this work without talking to the ops folks. So they went and delivered a logging solution and said, well, we heard you need to have encryption, and you need to configure our syslog in order to do this. And here's some documentation on how to do it. That didn't fit with how the logging system worked for the overall enterprise. So they delivered this thing, said plug it in, said login is important and it'll feed in your system, but they couldn't actually talk. The protocols and the system that they used involved two things happening that operations had to scramble for in the middle of a deployment. One, they had to build a shim that took logs from one system and put it to the other. And two, they ended up having two logging systems to support. So when someone called in and said, hey, we've got a problem, we're not getting these logs, There were multiple places they needed to look and multiple styles they needed to look at. The lesson of this is really, let's talk about communication. I mentioned that site reliability engineering is something that I found very important. Include operations, include the platform folks in the conversation from the very beginning of doing development. What are you guys doing? What do we need to know as developers? Before you even start coding, make sure that that conversation is there. The next story about this is actually something that we found was a lot more successful, where the organization did include. They were working on a large data system that would get lots and lots of files that users would submit. In the first meeting, the development team said, hey, we need a storage solution. What are we going to do to store what we expect to be terabytes and terabytes of files with long retention policies? That gave the platform team to take an idea they'd been working on, which was to use an object storage system for loading this data and say, in the meeting, why don't we use this as a solution? And then the development team from day one was able to develop against this target. Whereas if operations hadn't been there, the development team would have been told, oh yeah, we use a file share for all this stuff. I don't know here if anyone has tried to run a multi-terabyte file share and have it be reliable. Just don't, please. So having that communication allows that to happen. The next thing with communication is platform versus application. So for those of you who may be familiar, particularly with the Northeast Corridor, is it's an electric system. It means that your fuel is part of the track system. Well, this analogy holds similarly to whether it's platform as a service. Do you need a diesel engine where you provide all your components with you and carry your own fuel along? Or can you run on a platform where they provide the electricity? You know, things like logging, things like monitoring. Are those things that one can expect? So an example of this, where we were working with a client, the client said, OK, we're going to buy this software product. The software product came with their entire own clustering solution. Well, there was a lot of platform tooling already built around clustering and how to support this. The vendor came in and said, you need to do it all this way, and we expect some file storage like this. And because there wasn't that communication, things that the platform team expected to deliver ended up having to refactor because this application had very specific requirements and built in. Another example is microservices. We're not going to talk about containers here. We'll save that for plenty of other talks today. But this application team said, we're going to write some microservices. This is pretty cool. They did that on their own. They walked up to the platform team and said, here, we need the ability to do service orchestration. We need service registry. We need this entire container stack in order to be successful. Well, that wasn't a service that was offered at that point by the platform team. And because they didn't know it until they were having a, here's what you can expect to be deployed, kind of left the platform team scrambling. How do we re-engineer this? I'm sure people in the room, seeing a few looks, have had to deal with that, where it's, hey, here's this new software stack that we've built for you. It has all these dependencies. Sure, you can stand that up in 3 weeks, right? So making sure that the teams communicate what the infrastructure and platform teams can provide, can be expected to provide. An example of this that is really useful to offer, have a wiki. Have a page that says, here's what services we offer. And let that page be a description that says, you're a new developer coming in. These are the capabilities we offer. These are the tool stacks. This is what you can expect. It saves you 2 years down the line when an application team has written all this code and done all this work and says, here, we've fulfilled our contractual deliveries. Ops, good luck. What does that look like? Well, if you're designing your infrastructure and you're designing it and you don't know your workloads, so those are Boeing 737s sitting in the river. Oops. This train was built to handle very heavy cargo and was running fast along a track that was a standard freight track. The train went around the curve, slipped a little. Maybe it was rainy, maybe it was wet, maybe the tracks had sagged a little bit. I don't actually know the specifics of the story. And it dumped many tens of millions of dollars into the river. The lesson here is design for the appropriate load, but also know your workload. If you are an infrastructure or platform team and you get told, hey, we're rolling out this new application, the first thing you want to know, are these web servers? Am I running some heavy processing database servers? This is a batch job where if it loses a few in midstream, no pun intended, and that we can just restart those? Or is it something where it's user-facing, they're going to get a 500 error, and that's not good for us? So for a platform that I'm referencing a few times here, they bought some hardware because the procurement time was about 6 months. So we're going to buy hardware. Well, let's buy these nice 20-core Intel CPUs because there's lots of performance and we can put plenty on a blade. The problem was the application in this case had a lot of critical single-threaded processes. Those nice 20-core systems have a lower CPU, a lower megahertz count each, versus, say, a 10-core system that could run faster. The problem was this application then was going to run slower because it needed to run a single-threaded operation. In this case, it took about a 15% performance hit where they were being told that this new 8-figure hardware stack was going to bring better performance to the application because there wasn't that communication between the infrastructure side who was making that purchase and the application side who could have said, yeah, we care about individual core performance. The second lesson was, I mentioned a little earlier, this team decided to do object storage. Well, the hardware for that had actually already been purchased. You're probably going to guess next. They bought a SAN. So they had very fast, high-performance storage, and they wanted to run an object storage system. It works, really cost ineffective. All the redundancy that the SAN could offer wasn't needed for that storage system and was actually just inefficiencies that were put into the system. Don't think at the same time, I'm saying think about stuff and you're going, oh no, he's talking about waterfall. You don't need to think about all the answers. You don't need to worry about, does this object storage system have the highest performance? Or what are my IOP requirements? But being able to say the developers code this way means you can add resiliency or add scalability to it by adding more hardware later while still maintaining the similar interface. Take enough time to think through what you need to think through and get to the rest later. Let's talk about development. Anyone's development environment kind of look like this? Getting one laugh and a smile. So it's kind of like Thomas the Train. We're going to pull a few trains along, and that's our dev environment. It's a couple old servers that we found in the closet and threw on a switch and called it our new dev lab. That's not a good thing for going to a development team and saying, this is what it's going to look like. So in our case, we had a developer who said, great, this is a dev environment. I guess I'm assuming this is going to be like production. They designed a storage system that said, we're going to use VMware's underlying disk mapping system. A couple limitations in that for people who've worked with VMware. It's limited to 6, I think at least the version we were using, 16 simultaneous servers can share a disk. 2, our production environment didn't have one storage system that we could map to it because we had resilient storage systems. So they went to deploy this thing, said, please configure the shared disk. The infrastructure team came back and said, yeah, that's not technically possible. That led to a very mad scramble where the entire storage system of this application in mid-deployment had to be ripped out. Make sure your dev environment offers the capabilities. It doesn't need to be exactly like production. It doesn't need to have everything. But if it's using different hardware, if it's using a completely different software stack, if you're using virtualization and you're running VMware in production and you're running KVM systems in dev, you're probably not going to get a good representative system, and the team is going to end up having to do a lot of re-engineering. One thing that we have learned for dev that we found very powerful is how we deploy servers. In this project that I'm working on right now, we actually use the exact same software stack, in this case Satellite, to deploy to dev in production. We use RBAC to make it so that people can only deploy to their location that they should. But the team knows when I deploy a server into dev, it is not only the same server, but it's the exact same process that deploys into production. So we're always troubleshooting our process in dev. We're always deploying that same style and that same solution. And when there's an issue, we're also fixing that issue once because it's shared across all the teams. And it gives us a lot of trust that the systems being deployed in dev are what you can expect in production. And that includes all the way to our security stacks and some of the monitoring tools that are all there giving us some confidence that what the devs are building is going to work. Same thing with testing. You don't actually need to build a full hardware stack. You can scale your testing environment down and have a pretty good, I don't know if this works with the lights on, but this is one of the best model trains in the world where they've gotten awards. There's actually 4 parallel tracks in some cases there, different tunnels, different tiers. The model trains are climbing different elevations. That's good for testing. You don't need to build an entire 1,000-mile train system just to test your train. You can scale things down and get a good representative analysis. And this is excellent for cost savings. You don't need to buy, if you're doing a $10 million hardware stack and your boss is saying, why do you need to buy another $10 million hardware stack to test? Figure out what you can scale. Figure out what processes are important and which processes aren't. At the same time, one big warning that we did learn, when doing this, make sure you're including latency. Your users are probably connecting not from the test system on the next rack, but are connecting from either other locations or client sites or the internet. And your test, when you're building it at a small scale and you're saying, great, I'll just use drivers that are local, you miss being able to expose latency and other issues because of that limitation. Monitoring. I think this picture is pretty self-explanatory. The time to build and test your monitoring solution is not when you've already deployed to production. So there's 2 levels of monitoring. In this case, the team did a ton of development, released an application in production, it was slow. We had enough monitoring to know whether the software was running or not, but we had no idea what the application itself was doing. They went to operations and said, it's slow. Operations said, great, let's see your monitoring. What are the users' experience? They said, yeah, the users called and said it's slow. That's what we can tell you. That led to 3 weeks of kind of poking in the dark. Well, we changed this. Is it slow now? Yeah, it's fast. 2 hours later, hey, it's slow again. 3 weeks later, certain logs were on. There was log aggregation. We had enough data to be able to say it's there. The second level of logging is doing application performance monitoring. Now, you can bring in a tool like New Relic. You can bring in App Dynamics. Those are great tools that let you say, my application is slow. In this case, the application was fine, but it was making a call to another system, and that other system had heavy latency, and that was resulting in my application is slow. So the team spent weeks trying to troubleshoot an application that had no performance problems. Application performance monitoring allows you to see what your application is doing. This thread call is taking a while and enables troubleshooting. But if you don't have a lot of money, there are tools like Prometheus and others that are open source that allow you to instrument your code. Even something as basic as having your application team write a log that says started this call and then a next log that says call completed allows you to get enough data to get a feel for what it is slow. But these are things that have to be designed as you're developing your software project, because by the time it's in production, the dev team's like, I'm done, it's in maintenance, maybe your contract is finished and they're gone. They can't go put these instrumentation pieces throughout the application. Security. Anyone ever had a problem with security? Fortunately, we lost our head. Good, we got some new head nodders. Train inspectors are like security. If you go to them and say, my train is loaded, we're about to pull away from the station, and they come in and say, oh, we need to do a full inspection of your train's not going anywhere. Ever had to deal with an ANA where you're like, we're releasing next week, and security says, yeah, here's our checklist. This is going to take us 60 days, 90 days, 2 years. Communication being the theme. Talk to them at the beginning. So in this case, we actually had a project that was ready to go, and it ended up being delayed by about 3 months because security had to come in and run their checks because no one had gone to security and said it's coming. Have the discussion. Engage them early, even if it's just to say heads up. Most security folks, there are some that will, and you'll know them if you have to deal with them, but most security folks, if you go to them and say, hey, this is coming, we don't really have any answers for you, but we just want you to know it's coming, we'll look at you and say, great, thanks for the information. In a case with one of our clients, we were building a new infrastructure. We went to the security team, said, we need to tie into your IDS system. We don't know what our infrastructure is going to look like, but are there any things we should think about? Had a conversation, got some good answers. We all talked about it, walked away from the room and said, there's nothing to do now. 6 months later, when the government manager said, oh, we didn't think about security, and quick, we've got to do this, we were able to turn to them and say, got you covered. It's all solved. Here's the answers, and we know to re-engage them, and they're waiting to hear back from us. The next one is that perennial, we need to scan the environment. Well, if security hasn't been involved and know what you're looking for, what scan are they going to use? Oh, you're running Linux? Great, I just ticked every box that said Linux, and here's your report, and it says that all these SUSE controls aren't there, and you're running Red Hat. Never happened to anyone. Talking to them, going back to that wiki, having something that says, this is the software that we're running. One of the things that we found really successful, we have a list that says this is every operating system we have in our environment. We can tell security, you want to know what to scan for? Go look there. Saves a lot of emails and a lot of trouble. The lesson really here, engage regularly with the groups. Even if you have absolutely nothing to share with them of an action, just telling them what you're thinking or what's coming lets them start to think. And maybe they come to you and say, guys, here's something you might want to think about. And it allows you to react now rather than as it's trying to deploy. Automation. So if you've got automation in infrastructure and platform, it's like having an automated train. You do it once, and then you just let it go again and again. In the case of this, we worked with an application team from the beginning, told them that, hey, we're using Puppet. This is our automation platform. The application team said, cool. Turns out they hired 4 developers and wrote about 100,000 lines of Puppet code that deployed this entire complicated stack with Puppet. This turned out to be amazing because this application was taking a while. We switched operating systems. We went to the next version. We went to them and said, we're switching versions. They came back and said, cool, we need to do some minor refactoring of our code. Let us know when the servers are built and we'll just run it again. Other teams who heard they were doing it actually came back saying, please don't change. Our scripts are written exactly for this. Or our guy has this. Or our manual is written this way. Actually got all of the above in the case of this. And we weren't able to deploy. But for this one team that had done it, their 50-plus server application, it took them about 2 weeks, and they had a new dev stack running on the new operating system and just kept going and running away. It also gives you a lot more resiliency. We talk a lot, we heard a talk earlier about failure being a success. If you have automation for your deployment and something fails, it's a lot less stressful because you can delete it and rebuild it a lot easier than you can if it was someone spent 6 months manually deploying this. It lets you take risk. It lets you go faster. It lets you be more confident. Finally, let's talk about release management. If you've written all this software, if your dev team went off and did a lot of work, but you have no way to get into production, you're kind of missing a very critical vehicle in the process of making your train successful. In the case of one client that we had, they were working on a new project. They were getting closer to deployment. They went to ops and said, yeah, we're just going to give you a tarball with everything. It'll have everything we need. Not helpful, guys. Figure out what things they need, how you build software, what deliveries you could accept. In this case, we could accept either a container or an RPM. Providing a tarball was the effect of going to a platform team on the eve of delivery and saying, please re-engineer your entire process. If you've got an application team that said, hey, Node is cool. We heard last year here talking about how Node, you could write great stuff with Netflix. Well, if they come to you and say it's great, great. I want every single Node package and library that's available. Does your team have the ability to deliver that? The worst time to find that out is when the dev team was working, maybe off-site, came to you and said, here's our build file, and it expects to be able to say build, and there's a dependency library somewhere out there. Have the conversations with them, but be able to document and capture. This is how we release. This is what we can accept. This is what we can't. So we've talked through all this stuff. Went a little fast, had a lot of information. Hopefully this helps you think about some pitfalls and avoid some train wrecks. If your goal is to deliver very quickly and effectively, providing great customer service and low response times, awesome, we've got a high-speed train for you. If your goal is to deliver cost-effective solutions and massive processing, completely different solution, completely different answers, but you've built it. You have the ability to take that, to load your train, to put it on the platform, to know what you need to do. So I'd like to thank you all for coming. I know this was a lot of information. Appreciate you taking the time to talk. Here's my information. I am more than happy to swap ideas, talk with you, provide more information. Also, if you'd like to chat with different ideas, you feel either ValidaTek maybe can offer something that might be able to help you, or anything here sounds interesting and you've got an idea would like to build it, I would be happy to talk with you. So thank you all for coming. Appreciate it. And I think we have a minute or two for questions, hopefully.
When I've worked in government organizations, they typically have a robust governance and release and change control board processes. How do they integrate that with a DevOps environment, or get the two to work so that one doesn't slow down the other?
So that is an excellent question. And there's a couple different ways to solve it. I will give you the very short answer. One, if you need to release software and you're doing it in a DevOps process, you have a gate. Maybe it's your CI server. I focused on the application, the infrastructure side, but if you're doing continuous integration, you have something that runs a test that says, I'm ready. Your change board can become hit the release button. The automation itself allows you to be comfortable that it's all there. With a lot of these other processes, security, the control board, et cetera, they're looking for design documentation. If you've built a wiki, if you've put this information up and available, then instead of them coming to you at the last minute and doing an interview and saying, crap, give us all this information, the same thing you gave that development team at the beginning that says, here's what you can expect, becomes your documentation for the change board that says, here's what you're deploying on, or here's what we need to do. They actually fit very well if you think about the process not as I must do this, but my goal is to get that. Then you find the same information is available in a DevOps process, in a faster release process, and you can hand it off just by having the information maybe formatted differently or structured in a different way. I'm happy to talk more about that in detail. That's could be a talk on its own. Anyone else? Great. Well, thank you all for coming.